All right. Today is the 8th of May. We are almost there. Just a quick, there's two little lessons. We have to do one today, quick homework assignment today, and then one quick lesson tomorrow, which I hope, I hope I'm not underestimating these, but these will be notes today, notes tomorrow, quick assignment today, quick assignment tomorrow. I was ready to give you your practice quiz, and then I looked at it and I was like, oops, forgot a couple things. So that's why we want to go over this stuff. What we're doing today is multiplying rational expressions, which I know we already did, but I wanted to give you a day where the only ones that we're going to see are monomials. So that means that there won't be any plus or minus signs in today's notes or in today's work. So I don't even have examples scripted. And the reason we're not doing division is because after a long time spent yesterday battling with my software, it kept changing my division problems into fractions. And anyways, I wrote a note to the developers of my software, but I figured, if I were to put division ones on there, all you would basically do is flip the second one over and multiply anyway. So I figured like that's a small compromise, really. So today's I probably won't even put division in the notes unless you really want me to. But the idea is that we're just going to see multiplication. It's not so much the division and the copy.flop that I'm worried about, actually. It's just this whole idea of how do you do this. So all of today's problems are going to look very, very, very similar. And when I say monomial, what I'm talking about, again, is polynomials that just have one term. So like this is a monomial. It's just got one term. I realize it's got parts to it. It's got 5 and it's got some x's and it's got some y's. But because they're all attached by multiplication, that is just one term. So that is a monomial. And let's put it over another monomial. And then let's multiply it by another monomial. And then let's put that one over another monomial. So this is what we're going to practice today. And honestly, I just don't imagine that it's going to take more than a couple of examples for you to see this. I'm going to show you what I humbly think is the best way to do this. So it's going to wind up just being kind of a mash it up thing. But what I do want to do is go through, and I've schooled you on this before. You really should go through and tackle the number parts first, unless you're comfortable reducing big fractions. There were times on the worksheets when you got numbers, like if you multiplied straight across the top. I remember one problem in particular where you got 150, and then you multiplied straight across the bottom and you got 150, and you're like, jackpot, like I can just cancel all the numbers out. That's not really going to work here. So what I'm going to do is just focus not on the algebra part of this, but just on like the fourth gradey part. So you see this 5 and this 25. What can they reduce down to? 1 and 5. So the 5 becomes an unnecessary 1. We won't probably write that 1 unless we need it to hold the top together. And then the 25 becomes a 5. What else do you notice before we get started? So the 6 and the 18 can be reduced. Dividing them both by 6 produces a 1 and a 3. So at this point, if there's one thing that I can say definitively, it is that my answer will, like this isn't maybe we'll see what happens, my answer will have a 3 and it will have a 5. Any questions about that? Okay, so at this point, I'm going to show you again what I think is the best way. I've tried this, after so many years. Eventually, you just like to think you figure out after attempt after attempt after attempt, like, okay, this is the way that makes sense to teenagers. So what we're going to do, I call it the mash and minus. And so we're going to mash sideways and then we're going to minus downwards. You'll see what I mean. So first, I want to go straight across the top. And I want to take all my x's and I want to mash them. So if you look at the ones I'm pointing to with those red arrows, how many x's will that be total? X to the 12. Very good. Now do the same thing with the y's on top. How many y's will I have? Y to the 5. Very good. All right, so that's a mash. We're not quite done mashing though, because now we have to mash the bottoms together. And so again, I'm going to mash when I point to my x's. There's some x's on the bottom and some more x's on the bottom. How many x's will that be? X to the 5, right? Because we have x to the 1, you just don't see it. But then 4 more makes x to the 5. And there really is no mashing with the y's on the bottom because the only y is this fellow right here. And so I would just place a y to the 4th down there. Any questions so far? So the last part of this mash and minus is to do minus. And remember, when you have x's above other x's, you are dividing, but remember that to divide x's, you actually just subtract their powers from each other. So that shouldn't be too difficult for us. If I take, and again, I'm just going to copy down my answer. So here is my answer right here. So I'm going to place a 3 and I'm going to place a 5. Like once we figured out that, like that wasn't debatable or negotiable. The 3 and the 5 are staying. Now it's just a matter of how many x's do I get and how many y's do I get and where do they go? So if you take your x powers and subtract them, what's 12 minus 5? And since it's positive, we ought to put that on the top. Good. Now take your y's and subtract their powers. What's 5 minus 4? 1. And since it's positive, we're going to put that on top. And that is our final answer. 3x to the 7th y all over 5. Easy peasy, huh? All right, let's go again. Like I said, maybe one more. I don't think you need a lot of practice with this. Where you're going to run into trouble is if you go now and go rogue and start inventing your own process. Like you might be good if you invent something else, but you also might hit a speed bump. So reduce the numbers, mash sideways, subtract downwards. Easy peasy. All right, let's go again. Sorry for the crooked fraction there. That's terrible. I'm just gonna fix that. Oh, that's so much better. Whew. All right, what do we do first? Right. So again, we're not even thinking about X's and Y's and all that mashy stuff. We're just going to do the 4th grade part. And that is just basic reduction. So I see that a 17 and a 34 have a common factor of 17. So if I divide them both by 17, I get 1 and 2. Very good. And I also do see that a 12 and a 27 have a common factor. What is it? It is 3. So if I divide them both by 3, I get 4 and 9. And at that point, all the remaining numbers are what we call relatively prime. You know, I mean, all the ones from the top are relatively prime with the ones on the bottom, meaning you can't, no common factors. So what we know at this point in time is our answer will definitively have an 8 on top, because 4 times 2 is 8. And then 1 times 9 on bottom is a 9. Good. All right, now it's time to mash. How many x's will we have on top? Very good. How many y's will we have on top? Nice. All right, let's mash the bottom. How many x's? And how many y's? That's it. And at this point, if you can perform subtraction, which I don't say that in jest, you'd be surprised how many 16 and 17-year-olds think 5 minus 8 is 3. So assuming that we can subtract well, then we're really home free from here. So the last step is to do the minus, where we're dividing, but we're actually subtracting powers. So if we head downwards on our x's, what's 3 minus 11? It is -8. So where do you suppose we ought to put that? Very good. Now, when you put it on the bottom, you don't actually put it down there as a negative, right? So when you do, again, power of x is 3, power of x is 11. 3 minus 11 is negative 8. But that just implies that we put our x to the 8th on the bottom. We don't put it in as a negative. Putting it on the bottom accounts for the fact, it accounts for why we got the negative in the first place. Like there were more x's on the bottom. So, of course, when we clean them up, the remnants will be, of course, on the bottom as well. And then when you do your x's, what's 15 minus 2? Or your y's. Did I say x's? Your y's. 15 minus 2 is, and since it's positive, we will, and that is that. If you follow those steps, you'll always be done when you get to that point. You never have to go like, well, what else could I do? Assuming you've done the numbers correctly and thoroughly, and then assuming that you did the mash and minus correctly, there'll never be more work to do beyond that point. Yeah. Mhm. No, of course not. You'd be fine. But it's kind of like any other simplifying is like, or factoring, as long as you get it all out eventually, right? So like you're saying, what if I had like maybe overlooked the 12 and the 27? Um, I don't necessarily like your chances of seeing it later if you couldn't see it early, but no, if you see something later and you want to take care of it later, as long as we all collectively get to this, then you're good to go. Do you have any questions about this? Pretty simple, huh? All right, good. Well, I'm going to hand you out the worksheet. Let's get that sucker done. And then if you get done, this will be assignment 35. You could, of course, clean up assignments 32, 33, 34. And let's get all that done, water under the bridge. So tomorrow we can do double variable factoring, and then we'll be ready for the quiz. Sound good? Sure. Let me just stop my recording real quick, and then I'll do that for you.